I've learned a lot this morning from Dan Pink. So I also have good news and bad news. Okay? The bad news is that, well, I mean, you're at the trough right now of your cognitive ability, your mood, your performance are the lowest, right? But the good news is that this is the last keynote. And I'm literally standing between you guys and the food and drink and the party later on, okay? And I promise it's going to be better than the last episode of Game of Thrones, okay? All right. So with that, sorry? All right. I'll raise that, okay? You can help us raise that. So before I start, I just want to see how many of you here are finishing up the PhD that we are doing here at Pros, getting an AI PhD. Okay, excellent. So these are the people who attended the workshop, and we will actually finish this AI session here. Okay, and for those of you who didn't know what's going on, you guys should talk to the people who raised their hand, and don't miss that next year. Okay, so all right. So today, as Karen have said, I love to travel. And today, I'm actually going to take you on a trip, okay? And this is actually not an ordinary trip where we're going to a place, but we're actually going to the future. Okay, so to do this, we have to go back in time a little bit and look at the history, and then look at the current state of AI, and then we're actually going to give you a choice. We're going to teach you how to choose your AI so that you could shape your future, okay? So with that, let's start from BI to AI, okay? So to understand AI, we really have to understand BI first, okay? And so with that, I could use a very simple illustration of this history, using basically these data that you all have seen before. These are stock trading data, right? And you all seen them all. You all have seen them in the financial news. When you get data like this, you look at the data point, right? And after a while, you said there's actually too many data points for me to look at. Then what do? You basically summarize them, right? With some statistics, with moving averages, resistance points. There's some indicators of what these time series of stock is doing, okay? So basically, you are trying to get a sense of what this data is doing without actually looking at every single data point, right? And this is what we do in descriptive analytics. So you're simply describing the data by summarizing it so that you don't have to examine every data point, right? So after a while, you can say, well, I could do a little bit better than this. I could actually build a model. So the model also summarizes your data, but what's the advantage of having a model? The advantage of having a model is that now you can actually extrapolate to regions where you don't have data yet, okay? That's the beauty of having a model. You can extrapolate, right? So in this case, we extrapolate to the future, right? And what you do there is you basically move into what we call predictive analytics, right? Predictive analytics is obviously one of the biggest use cases of predictive analytics is forecasting, right? We will talk about some other use cases that's not forecasting later on, right? And you could do this for a while, and then, but having an eye into the future means that you can also tell people what to do, right? For example, if you want to actually make money, this is actually a good time to buy, right? And this is actually a good time to sell, right? And then this is what we actually call prescriptive analytics. You're actually prescribing actions for people to take, right? Okay, so this is actually a very, I would say, brief and short history of business intelligence, okay? And I'm sure a lot of you have seen reports and dashboards of, throughout your work. And all of those are basically descriptive analytics, right? So basically, descriptive analytics is all about summarizing data, okay? And that's really just any data visualization is an example of that, right? A lot of people actually misunderstood what predictive analytics is, okay? And a lot of people think that it's all about forecasting. And as I mentioned before, yes, forecasting is a very common and one of the biggest use case, but it may not be the most useful things, to look at predictive analytics, right? Like this way. So predictive analytics is all about estimation. It's all about building a model, right? And using data that you have to make an estimate of the data that you don't have, okay? So you said, well, how did I look at forecasting in that case, right? I mean, basically in forecasting, right, the data that you have are basically historical data. And the data that you don't have are basically future data, right? So that's actually a more general way to look at predictive analytics. And there's actually many, many examples of predictive analytics that's actually not in the temporal domain, okay? Such as things such as age estimation, right? You may have images of a person, and you're trying to estimate how old they are, right? You can have demographic inference. You may have speech data, right? And you're trying to infer how the age and gender of or different demographic characteristics of this person, right? And there may be sentiment analysis, right? So sentiment analysis, the data that you have is basically text, okay? And you're trying to infer people's opinions about certain things, all right? So basically, to understand predictive analytics, you really just have to ask yourself, what data are they using to estimate what other data that they don't have, that they would like to have, okay? All right, so that's actually a much more useful way to look at predictive analytics. Now, what about prescriptive analytics? Right? Prescriptive analytics, on the other hand, is all about optimization. Right? And the simplest example of prescriptive analytics is essentially a GPS navigation system. Okay? Now, think about what a GPS navigation do for you. Right? You tell me where you want to go, and I basically prescribe you a sequence of action to get there. Okay, that's prescriptive analytic system, right? But think about this. Why is it all about optimization? You have to think about, why do you think they prescribe this particular route, right? There's actually infinite number of routes to get from point A to point B right there, right? You can actually go around this way. You can kind of go around the river. And you can even go around the globe and come back the other way, right? I mean, that's obviously not very optimal, right? So what are they optimizing? GPS prescribe you that route because early GPS probably optimized for the shortest distance, right? But today, GPS actually optimizes something else. So it optimizes for the shortest travel time. It takes into account of traffic, right? So they prescribe you that particular route because it's optimizing something underneath. Okay, so basically, to understand prescriptive analytics system, you really just have to ask yourself, what is it actually optimizing underneath, right? Okay. What are some other examples of prescriptive analytics system that you know of? Anybody want to shout out? Nobody? You guys are very quiet. You guys really at that trough now. Right? You gotta have a little recovery here. Okay, let me give you a simple example. Search engine is actually a prescriptive analytics system. What is search engine optimizing? Relevance, right? Okay, relevance. Just like in the case of this the GPS with the route, there's infinite number of web pages that you could look at. Why did they prescribe you this 10 in this page? Because these are the 10 that optimizes relevant to your query, right? Okay. And likewise, recommender system is also a prescriptive analytics system. There's virtually infinite number of movies or music or products that you could buy, or right? Why recommend this set for you? Because those are the ones that optimize the similarity of your preference and the content, right? How about another one? How about like bit price generation? What are they optimizing there? This is an airline use case. I know there's a lot of airline participants here. What are they optimizing? Revenue, right? So, but what is bit price generation telling you to do, right? Remember I said prescriptive analytics is they prescribe you actions to take, right? Bit price generation is really telling you sell only above this price, right? That's what they prescribe. There's infinite number of prices that you could sell at, but only sell above this price. This is what they're telling you to do. This is the action that's prescribed. Okay, so now you know a little history of BI, and you know a little bit deeper about prescriptive analytics as well as predictive analytics, right? The question is, what's next? What's next? Guess what's next? Next? Machine learning? Not quite. Okay? It's really artificial intelligence. Okay? The next thing that comes is artificial intelligence is really just the automation of decision and proper execution of subsequent actions. That's what AI, I would say that that's really the beginning of AI. It's not really full-blown AI. It's actually the inception of AI, okay? So now, to put this in picture, right? Really going from data to decision to action, traditionally, that has been a human's job, right? We decide what to do. Regardless of what the data show us, we decide what to do. Now, but if you actually are able to go from data to decision to actions automatically, in an automated fashion. That's the beginning of AI. Okay, that's the beginning of AI. And this is actually here already today. Okay, so today we have, for example, algorithmic trading, right? You could recommend me what stock to buy, what stock to sell, or show me the performance of trajectory, how this stock is trending, and all that stuff, right? And ultimately, I have to click the buy button in order to execute that trade, right? But today, with algorithmic trading, you could just buy and trade on my behalf. How many people here actually use robo-advisor to manage your portfolio? Some do, okay? I actually use robo-advisor. I don't have time to manage my portfolio, okay? So why do you want me to click that buy button in order to buy, right? If you know what's the optimal stock to buy and sell, you should just buy and sell on my behalf, right? If you wait for me to click that buy button, it's actually less optimal because when it's the perfect time to buy, right? It may be midnight or something like that, or maybe an hour that I'm not available, right? When I'm able to check my recommendation when to buy, right? It's actually maybe hours later, maybe days later, right? It's no longer optimal anymore. So it's actually better for the algorithm to make those decisions for me, right? Another example, automated loan origination, right? Why do you need a person to check off all these boxes to give people a loan? If they meet the criteria, just give them the loan, right? So now going back to the geospatial domain, right? What's an example of a prescriptive analytic system? The most common one? Just trying to see if you're paying attention. Yeah, GPS, right? Going back to the GPS example. Why tell me what to do to get home? Just take me home, right? That's the beginning of AI, okay? That's the beginning of AI. Now, these AI, I would say that is not, I call it the beginning of AI because these AI are not really smart yet, okay? So the really, really important question that we should ask is that what makes AI intelligent? What makes it actually smart? And this actually leads us to the topic of dynamic AI, okay? So we can actually give a little bit of a definition of what AI is, and that's actually a very, very difficult term to define. And I want you to take that with actually a little bit of a disclaimer because the definition of AI actually evolves. It actually changes over time. Okay? Traditionally, people often think when optical character recognition actually was available, people think that was AI. Because now machine could read prints. It could even read your handwriting. Wow, that's AI. Now your phone could do it. Right? Nobody thinks that's AI anymore, right? So take this definition with a little bit of a grain of salt, right? At this moment in time, the way I like to define AI is really that it's a machine mimicry of certain aspects of human behavior and decision with two very important characteristics. One is the ability to automate decisions and subsequent action, which you've already seen some examples of this already, right? Now that's one criteria. You have to be able to automate human decision and action. And the second one is it has to be able to learn. It has to be able to learn and become smarter over time, right? The more you use it, the smarter it gets. That's what makes it truly intelligent, right? Otherwise, you have an AI that's actually not very smart after all, right? Okay? So what's not AI is machine learning is actually not AI. Just because you use machine learning to build a model, it doesn't mean you have an AI. And this actually is one of the biggest, I would say, confusion in the industry. A lot of people in the industry say that, oh, I use machine learning to build my model, so I have AI. And that actually comes from this picture that's actually it's a very popular picture that's been circulating around the internet. Basically says that deep learning is a kind of machine learning is a kind of AI. How many people have seen this picture before? I'm sure a lot of you, if you actually Google for AI, machine learning, you probably will have seen this picture. A very popular picture. It's even on Wikipedia. So it's got to be right? It's on Wikipedia, right? But not quite, okay? So the reason that this picture is actually somewhat confusing and misleading is that deep learning here, in fact, is a kind of machine learning. However, machine learning is actually not a kind of AI, okay? Now, to give the person who created this image a little bit of credit, okay, I could understand why he would put machine learning inside AI. Because today, pretty much all AI uses machine learning, okay? So machine learning is actually part of AI, right? So it kind of makes sense to put them inside AI, right? Does it make sense? Right? But why is this a problem? This problem is that it's created what we call a inconsistency in this Venn boundaries, okay? Deep learning is a kind of machine learning, and machine learning is a part of AI. It's not a kind of AI, but a part of AI, okay? So this should be the way you interpret this picture. A lot of people would just say that machine learning is a kind of AI, which is actually not true, okay? Now, the reason this picture is actually very, very misleading is that, let me give you another example, okay? So V8 is a kind of engine. We know that V8 is a kind of engine in cars, right? Those of you who work with cars, I'm sure you know that, right? And the engine is actually a part of a car. It's used in every car, right? So now, what happens if you don't show those Venn boundary there? You could very easily come to the wrong conclusion that an engine is a kind of car, which you know is ridiculous, right? Engine is not a car. Everybody knows that, right? So this is the danger of this picture, okay? So this picture, we should really just throw away. And let me see if I can give you a better picture. Okay, so this better picture actually starts with data, big data, okay? Now, data scientists basically turn this big data into a model, right? And we use a very powerful tool to help us do that. And that tool is machine learning, right? Those of you who's in the workshop, remember? Machine learning is a process of turning data into a model. Remember that? Okay? So basically, machine learning here is really both a noun and also a verb, okay? As a noun, it's just really a bunch of algorithms that data scientists use. Right? I mean, I could fill up several more pages with names of algorithms that will just confuse you, right? But I won't do that. Okay, now, notice that deep learning here is, in fact, a kind of machine learning, as I said before, okay? So, indeed, deep learning is a kind of machine learning, but machine learning as a verb is really just a process of turning data into model, right? Depending on what kind of data you have and what kind of model you're trying to produce, right? And data scientists basically go and pick different algorithms, right, to produce the model that you want, right? Okay, so now once you have a model, what do you do with that? You have a model, you feed them with new data, you're going to get some new analytic results out of that, okay? And some decisions have to be made about what to do about those results, right? And these often involve some actions being taken, right? And actions in the real world has some consequences. These are the outcomes, right? And these outcomes need to be fed back into your analytic system in order for the system to work well. Okay? So the feedback has to feed back into your analytics. All right. Now, today, I would say a lot of the decisions are still, I would say, executed by human. We still decide what to do, right? Traditionally, that has been the way, and I think today is more or less that way too. What about actions? Actions today are, some of them can actually be automated by machines already, right? Especially in the digital world, a lot of these actions can already be automated by machines. But in the physical world, a lot of this a lot of these actions are still taken by human, right? Because robotics didn't actually advance as quickly as we wanted to, okay? And feedback also traditionally is also collected by human as well. So we collect feedback with surveys, right? And obviously surveys not very fast. It's actually very, very slow, right? So this can't happen in real time. But in order for the system to work well, this feedback needs to happen in real time, right? Think about the example of a GPS again, right? So what is the feedback in the GPS navigation system? Anybody know what the feedback is? The feedback is that blue dot that shows you where you are. That's the feedback. Okay? Now imagine how good and how useful that GPS would be if that blue dot update, the position of that blue dot was delayed by like 2 minutes. How good do you think that GPS would be? How useful would that GPS would be? You say, turn left here, and they say, wow, there's a wall here, so sorry, I can't go there, right? So it needs to really be updated in real time, right? So the first thing we have to change is that, this feedback had to be tracked automatically, okay? And this can be done very easily today because all it takes is some engineer to write some code to track what's going on, right? So, and this is especially easy in the digital world, right? But even in the physical world, this can start to happen already because we now have IoT and sensors that can actually track what's going on in the real physical world, right? So this is happening. It's actually, definitely we can track feedbacks, right? There's no excuse. Now, if this model here, okay, this model here, if it's actually good enough, basically, we could automate the decision there as well, right? So now what do I mean by this model is good enough? The model is good enough when the output of those models match a human expert's decision. That's when I mean the model is good enough. If the model do not match a human expert's decision, then the model can improve. You could do better, right? We have to train it better so that it actually do better, right? So now, in the rare cases when humans disagree with the machine, right? Yeah, you still have a little bit of sliver of yellow there. That's why human can still override, right? But in most cases, if the model is good enough, it means that the output of those models should agree with the human expert pretty much all the time, right? Nothing's 100% in statistics and machine learning, right? So should pretty much agree with the human expert all the time, right? So therefore, you really don't need to have the human decision there right there, right? Because if you do, what will happen? You basically will be saying that, yes, I agree, I agree, I agree, I agree, I agree, I agree, go ahead, do it, I agree, all the time. Pretty much all the time, right? So why do that? You should just automate it, right? If you don't, your competitor will, and they're going to be able to move much faster than you do, and you'll be forced to automate this process, okay? Now, what about actions here? Action, right, like I said before, in the physical world, nothing we can do about that yet, right? But definitely in the digital world, we could pretty much automate everything. Because all it involves is some execution of some code, right? To execute something in the digital world, right? So now, if you look at this feedback loop here, there's virtually no human involvement, only in the rare exception that, when the human disagree with the machine, right? So there's two implications of this. One is that this loop can actually go very, very fast, right? Because we're the slow one, right? We're the slow one, right? We're the bottleneck here, right? And the other one is that because everything is actually automated by machine here, everything can also be tracked digitally, and they become digital data that we could track, right? And these digital data can actually be fed back into your big data store, right? Because the data is data, right? You feed this back to your big data right here. Now you have new data coming in, right? That means you can actually, with these new data going through your machine learning process, all right, now you have a way to update your model, okay? Now, this model gets updated pretty much every time you use the system, right? Every time you use a system, right, new data will be fed back into your big data store, and you go through this machine learning process again, right? Now, the models, because they've seen new data, the model gets updated, right? The model becomes a better model than before, okay? So every time you use this, right, this basically becomes a better model, right? And you could do this completely unsupervised in automatic fashion, but usually that's a bad idea. Usually, you want to have some human supervision, okay? Now, if you use this system over and over again, basically this model would become really, really good model for this process of going from decision to actions to outcome. It gets better and better at modeling that process, right? Okay. Now, this is actually what we call the learning loop. This is actually how AI learn and how AI becomes smart, okay? Because every time you use the system, right, as I said, the data becomes digitized and then fed back to your big data store, right? Now you have more data, right? Basically, the AI is seeing more situations, right? And now your model gets updated in an automatic fashion. Now it's a better model. So that the next action it prescribed is a better action than before, right? It always gets better, okay? Now, I just want to illustrate the power of this learning loop with the example that some of you probably have heard of this story in the news. The program AlphaGo is able to beat the world champion in the game of Go. How many people have seen that in the news? Okay, a lot of you have seen that in the news, right? How do you think the program AlphaGo is able to beat the world champion? I mean, this program actually coded up by I would say engineers, right? They wrote this program, and they are nowhere near, in terms of skill compared to this world champion in the game of Go, right? If you want to train it with the, actually, in fact, AlphaGo wasn't even trained with the gameplay from this world champion either. So how do you think this AlphaGo is able to beat the world champion? Okay? This really comes down to the speed argument, okay? So AlphaGo, when it becomes good enough to play a human, right? So AlphaGo was trained with professional players' gameplay, right? So they actually, after a while, the AlphaGo is able to play a real professional Go player. But they're nowhere near the world champion, right? These Go players are much, their skills actually nowhere matching this Lee Sedol here. However, once you're able to make AlphaGo be good enough to play a human, what can they do? They can actually make AlphaGo play against AlphaGo itself. Okay? Guess what the implication of that is? The implication is that now AlphaGo can make all the mistake that a human can ever make in their entire lifetime, right? And learn from it and never make those mistakes again, right? Because if you play a human, how long does it take you to play a game of Go? Do people play Go here? Anybody play Go here? Probably take you like 2-3 hours to play a game of Go, right? Depending on how good you are, the game may be longer or shorter, right? But if you make AlphaGo play against AlphaGo, you could literally play 1 million games a day, right? So you can actually make lots and lots of mistakes and learn from those mistakes and never make those mistakes again. And that's how you become smart. That's how you become better than the world champion in Go. Think about the implication of that, okay? All right. So now, hopefully by now, you understand a little bit about how AI works, right? Yes, no? Yeah? Okay. So now if you understand how AI actually works, the next thing is now you have to be able to choose the AI that's right for your business, okay? Now, a lot of companies, when I talk to them, they say, well, what can AI actually do for me? What can AI do for my business, right? That is actually the wrong question to ask. The wrong question to ask, okay? The reason is because AI can pretty much do anything that a human can do, provided that you can fully digitize the process, right? So, because the key here is really fully digitized, right? If you can fully digitize the process, you will have the data to train the AI to mimic what we do, okay? So the key word here is fully digitized. Right? If you have something that requires 10 steps, right, and you digitize 9 of the steps, don't expect AI to be able to fill in that last step for you, right? There's no data for it to do that, right? So it won't be able to fill in the last step for you, right? So the AI cannot do a lot of things today, not because they cannot do it, it's simply because we don't have the data to train it yet. And those data may be very, very difficult to digitize and very, very difficult to get, okay? If we could digitize them, we have data, we could train the AI to do it, okay? So the real question that a company should ask is, what can you digitize, right? This is another argument why you need to digitally transform your business, right? Because now you will have those digital data to train your artificial intelligence, okay? All right, so now because AI, all you really need is just data, right? So there's actually lots and lots of applications of AI out there. There's literally, I would say, tens of thousands of applications of AI. But there's actually 4 that's actually very, very important today, okay, in the recent years. And let's go through each one of them. The 4 major categories of applications of AI, the first category is basically what we call perceptual AI, okay? So perceptual AI are basically, think of them as basically chatbots and digital assistants, right? You have Cortana, Alexa here. We see earlier with the demo, like people are using Alexa we could actually book airlines through just talking to Alexa, right? So these are what we call perceptual AI, right? Sometimes they're also called cognitive AI because these are actually AIs that actually mimic higher cognitive functions of a human, such as image recognition, speech processing, right? To understand what you want, right? So these are cognitive AI, perceptual AI, right? And the biggest applications of perceptual AI is in this human-computer interaction. And there's no surprise to that, right? Because now if you have a machine that could, see things as you do, can understand your language, can speak to you using your language, so you didn't have to write code, right? Of course you're going to interact with the machine a lot better, right? No brainer there, right? Okay? So that's the first class of applications of AI. Perceptual AI, cognitive AI, okay? Now the next class is really what we call internet AI. Internet generates lots and lots of data, right? And if you feed those data into our AI system, our learning loop, right? These AI can actually learn your preference. They can actually learn what you like and what you don't like, right? And Amazon and Netflix are some of the early pioneers of this, right? And basically, the biggest applications of internet AI is recommender system. And now we actually use this for lots of personalization applications, right? Because now if you know what people like, what they prefer, right, you can actually personalize their experience for them, right? So this one is actually very easy, right? I'm sure a lot of you have experienced this. If you watch Netflix or something like that, right? Or if you subscribe to Spotify, you experience this, right? So this is basically internet AI, and sometimes they call personalization AI because the biggest applications of this internet AI is in personalization, okay? Okay, so the third class that's actually very, very important today is autonomous AI. Autonomous AI, guess what the biggest application of autonomous AI is? Self-driving car, right? Biggest applications of autonomous AI is self-driving car. They actually drive a lot of development there. But autonomous AI actually have lots of applications beyond self-driving car, before autonomous vehicle. It actually has applications in robotic, IoT, connected machine, right? All these applications where machines or parts of machine need to talk to other parts of machine, right, to resolve conflict so they actually could function autonomously. Okay, so that's autonomous AI, right? And the last class is really what we call business AI. Now, business AI, the biggest applications is business decision and automation. You need to automate business decisions and decision as well, right? So now these tend to be very, very specific to the business domain, right? For example, you can see some here, right? So fraud detection, right, is one of them. Some experts have to decide, look at some traffic pattern or behavior pattern, determine whether this is a fraud or not, right? Now, if you actually give this data to the AI can actually look at these behavior pattern and decide for you whether this is likely to be a fraud or not, right? And likewise, algorithmic trading, right? And analysts traditionally have to look at the stock market and actually decide which one stock to recommend, which one not to, right? And if you give all this data to an AI, the AI could actually help you make those decisions, right? And same thing as I would say, in machine-aided medical diagnosis, right? Watson here actually do a lot of machine-aided medical diagnosis early on, right? Now they start to branch out to other areas as well, right? So PROS here is also one kind of business AI, right? What are some of the decisions that we automate, given your understanding of PROS? Pricing, right? Infinite number of ways to price your product, right? How should you price it, right? And which opportunity to go after, right? There's a decision that people have to make at some point. Now we could just automate those for you. Okay? All right. So that's the four, I would say, biggest class and most important class of AI application today. Part of, I would say, knowing how to choose AI that's right for you comes down to the ability to spot some pretenders. Okay? So because AI is a hype now. Everybody want to jump on this AI bandwagon. Pretty much, if you're in the Silicon Valley, right? If you're trying to get VC funding, if you don't have AI in your technology portfolio, you're probably not going to get funded. So everybody want to say they do AI, okay? But are they really doing AI? And are those AI actually useful for you, right? So if you're a technology company, right, what do? You identify a business problem, and then you basically build some business logic, right, to address those problems, right? And you package it up, and then you sell those technology. That's what tech companies do, right? Now, because everybody wants to jump on this AI bandwagon, now these technology companies, very easily, they could just say, hey, you know what? I could just put a perceptual AI on top of my business logic, and now my system is smart. My system has AI in it, right? Now, that is actually not a false claim, okay? Because as you know, right, these perceptual cognitive AI, it is actually a very, very important class of AI application, right? And they do have AI now in their system. But is this AI really going to help you, right? Now you understand how the learning loop works, right? Now that you understand how the learning loop works, how do you think this system is going to evolve as you use the system? Right? Basically, every time this person uses their system, right, this perceptual AI will learn to interact with this person better and better, right? For example, this AI may actually learn your business domain jargon. It may learn the way you talk. It may learn your accent. It may even learn your humor or sarcasm, right? So it will really learn how to interact with you really, really well the more you use it, right? This is how the learning loop works, right? But what's actually solving the business problem? The same logic, right? That logic hasn't changed at all, right? So this AI, even though it is an AI, but it's not actually going to help you solve your problem any better. It will interact with you better over time, right? So I'm not saying that these perceptual AI have no value. They do have value. But the value proposition is really in that they actually increase the productivity of your employee. That's the value, okay? Because now you can work anywhere, right? You can work anywhere you want, right? You could wait in line for coffee and then ask your chatbot and digital assistant to set up a meeting, have a reply to an email, right? You can even ask it to fetch you some data, right? But remember, think about this example of fetching data for you, right? Fetching data is really just an SQL query that you write, right? You could do that when you're back on your desk. You simply give this AI the ability to execute that query for you wherever you are. That's all, right? But it's the same query. The query did not change at all. It's not any better query than before, right? Okay? So now the difference between this type of AI, this cognitive AI, and business AI is that these business AI actually directly solve your business problem, right? So every time you use it, how is this learning loop going to react? This learning loop is going to learn how to solve your business problem better and better every single time you use it, right? So just using one of the pros tool application that we built, right? Opportunity detection. Basically, it recommends opportunity for salespeople, right? And the salespeople can either accept the opportunity or reject the opportunity. And based on those acceptance and rejection of the opportunity, this AI will learn what kind of opportunity this salesperson actually like, and recommend more of the opportunity that he actually like to pursue, right? And we can actually take longer-term feedback data, such as which of these opportunities actually close, and use those data to recommend opportunity that's actually more appropriate for this salesperson. Maybe this salesperson is really ambitious. He said, I want to take the biggest deal, right? But maybe he can't close all of them, right? And that's not good for anyone, right? So this AI will actually learn which deals actually close and use that feedback to update their model so they actually recommend more appropriate opportunity for this sales. Okay? Solving your business problem better every single time you use it. That's the difference between this business AI and this cognitive AI, right? And so the value proposition for this business AI is that every time you use it, you actually get a better and smarter decision. Okay? All right. Now, so what can these 4 kinds of AI actually do for you? What can this AI do for you? Well, so one thing is that it can actually improve your customer experience. Okay, so the AI actually could do a lot of things for you. Okay, like I said before, lots and lots of applications out there, right? But there's actually 3 major business outcomes that they could drive. 1 is improve customer experience. 2 is actually increase efficiency of your business. And the third one is actually help you grow revenue. Okay, lots and lots of things that AI can do. And there's actually lots and lots of AI out there, right? But these are the 4 major class of AI, and these are the 3 major business outcomes that it can drive. Okay, so now let's say, so how do you actually choose your AI, right? That's actually right for you, right? So it really depends on what kind of business impact you want to have, right? If you want to have improved customer experience, which kind of AI would you pick? Yeah, perceptual, right? Right? Obviously perceptual, right? But also internet AI as well, because if a machine actually understands what you like and what you don't like, you will also get a better customer experience too, right? All right. Now, what about if you want to increase efficiency, right? For example, reducing costs, right? And raise productivity and increase throughput. All these things are part of increasing the efficiency of business. What kind of AI would you choose? Why? What? Louder, come on. Business? Okay. Yeah, they could do that. Okay, so certainly, perceptual AI could do that too, right? Because what did I say about perceptual AI? They increase productivity, right? So if you increase employees' productivity, you increase your business efficiency that way, right? And also, certainly, you could simply replace the human with a robot, right? Using autonomous AI right there, right? So you could do that too. And there are actually some, I would say, business AI that actually is designed specifically to make certain business process a lot more efficient, right? So this is actually a very crowded space here. Lots and lots of AI out there to increase efficiency. Lots and lots of it, okay? That's why it's almost pretty much full there, right? And the last one is, what if you want to grow revenue? What if you want to expand the top line, okay, and drive profitability? Which kind of AI would you pick to do that? Right? Pretty much is business AI there, okay? All right? Okay, now, don't be surprised to find that perceptual AI can actually help you drive revenue. In fact, every one of these AI can drive every one of these business outcome. But it's not direct, okay? Sure, perceptual AI, this cognitive AI can drive growth and revenue. Yeah, if you make the customer experience better, then the customer is going to love you, and they're going to buy more from you, so you will have increase growth in revenue, right? But look at how many steps is removed from that, right? It's not a direct impact, right? Okay, so big dots here basically represent these are the most direct impact they could have on this business outcome, okay? So hopefully by now you know how to choose the AI that's right for your business problem. Yes, no? Yeah? Okay, excellent. Okay, so now you know how to choose AI for you, right? Now you can shape your future, right? So what would the future be like? So AI is actually a little bit scary in some way, right? So have you ever actually used the app Waze? I'm sure a lot of you have, okay? So think back in the first time that you used Waze, right? Have you experienced that, why would Waze kind of direct me to this little small alley that I never go this way, okay? Do you have those experiences? Yes? Yes? Right? Yeah, I hear a lot of yes and nodding heads there, right? Okay, so that's essentially a problem that we're trying to overcome, okay? Waze is actually recommending you something, right? And you don't know why it's recommending you that. So you kind of find it strange, okay? Now, this is actually a problem that I actually have to solve. I encounter this. I actually was speaking in a conference in Istanbul, and I really have to just cross this Bosphorus Strait right here, going from this green dot to this red dot right here, okay? And guess what? If I key this into my GPS navigation system, right, you just say that, okay, now you can either take the ferry across, right, or you can kind of drive around in this roundabout way, okay? Now, this is kind of strange, okay? The reason why it's so strange is that, if you actually look at the distance of where I want to, to the point of where I want to go, right, I'm actually spending more time getting away from where I want to go, and then the last, a third of the time, I'm getting close to it, right? This is kind of weird, isn't it? Okay. It's not so weird in the geospatial domain, right? In this map, we understand how geography works. We can't really, drive across the strait right there, right? So it's not so weird for us, But think about what this would be in the algorithmic trading domain. Okay? What if I want to invest $1 million and get back 400%, like get to positive $3 million in 6 years, right? So basically, I sink in that much money, and I want to get back to here in 6 years, right? Now, what happens if the prescription was that you have to lose $2 more million before you make those money back? Do you believe that? Is that easy to swallow? Stefan, right here? Not very easy to swallow, right? That's a really tough decision, right? Do you want to follow this recommendation, right? What if you put in some constraint? We say like, okay, I want to don't lose any more than $500,000 at any given time, right? So what if the prescription was this? You don't make any money for the first 5.5 years, and then you make them all back in the last 6 months. Do you think you can sell this to your CEO? Not easily. Not an easy sell, okay? It's going to be a very tough sell, okay? But what if this is the only way, right? Think about what would happen if, in this case of this map here, right? What happens if I don't trust the GPS? You say like, I really want to go there. I see that tower, I want to go there, but why is it telling me to go this way? Why is it telling me to go further and further away, right? I'm going to not trust the GPS system, and I'm going to go this way. And guess what? Eventually, I am going to run into water, right? And guess what? I have to go back the same way, right? And I'll get to my destination much, much later, right? You need to learn to trust AI, okay? Today, I would say we need to learn to trust AI, right? Today, the biggest, I would say, barrier that prevents companies from realizing the full potential of AI, that is actually not an AI or technology issue. It's actually a trust issue, right? People don't trust AI. So how can we learn to trust AI better, right? How can we learn to trust AI, right? So let me just illustrate this with an example of how AI actually shifts a human's job, right? So for example, using the sales rep as an example, right? Everybody understands how salesperson work, right? So for a salesperson, typically, traditionally, what they do is that they have to look into their CRM, right? Look at the data, and then basically analyze those data, analyze transaction data, and then basically identify opportunities to go after, right? And then what do they need to do? They find the opportunity to go after. They need to start contacting these leads, and then coordinate and maybe set up meetings, and eventually actually go meet them, right? So today, we can actually automate some of this already. We have a tool called opportunity detection. Basically, we simply have to give these AI our CRM data, right? Now, this AI can analyze this data and actually recommend an opportunity for the salesperson, right? The salesperson simply have to say, either I accept this opportunity or reject this opportunity. And as he do this AI will basically learn which type of opportunities this person like and be able to recommend better and better opportunity for him, right? And eventually, pretty much, at some point in the future, right, this AI will be so good that every single opportunity they recommend, the person basically accepts it pretty much all the time, right? In that time, basically, we could just simply automate this, right? There's no need for the person to say, yes, I accept, I accept, I accept, I accept, I accept, over and over again, right? You just automate it. So basically, just take off this decision process, right? Basically, the person will basically take everything that's recommended by this AI. Now, then what do you need to do? You still need to write email to this lead and basically coordinate and set up a meeting and go meet them, right? But why stop there? Why can't you just give these AI your email, right? And then this AI could learn the way you write and then basically craft an email for you. Or you could simply just say, okay, well, I like this email, let's send it. Or I say, I don't really like this email, let me correct a few words here, right? And as you correct this and reject this recommendation from this AI, the AI actually learn how you write better, right? And eventually, they will actually be able to learn to produce an email that's just like the way you would, okay? And guess what? You automate that process again, right? Hey, but after that, pretty much you just have to coordinate and set up a meeting, right? But why do you stop there? You can just simply give your AI your calendar data, right? And have AI essentially learn your travel habit, right? For example, I don't like to fly red-eye flights, right? And I like to fly in the morning or whatever. It will be able to recommend you an itinerary for you to go and meet your customer, okay? And you could also say now, okay, I don't like this itinerary, right? Give me another one. And as you do this AI will actually learn your travel habit better and better over time, right? Eventually, they are going to recommend itinerary that you like pretty much every time. It gets better and better at recommending you this itinerary, right? So eventually, you can just automate that process again, right? So pretty much, eventually, you just have to go and pick off the list and go meet your prospects. That's all you need to do, right? We are basically exchanging data for automation and convenience, right? Before, a salesperson had to do all these things, right? And imagine how many prospects can he meet if he had to do all this stuff? He may only be able to meet 5 prospects a month. If your AI doing all these things for him, maybe you can meet 50 or 100. So imagine the efficiency gain here, right? So, okay, so you may say like, well, why not just automate this meeting the prospect there? Why can't we do that? Well, I mean, we're not quite there yet, okay? Because these are physical work, right? So we don't have any data that keep track of our physical work, right? So we don't have data to give to AI to train them how to go meet the prospect yet, right? And these are what we call called digital work, right? So we actually have data that we can actually use to train our AI. Okay? Now, if you actually look at the way that humans do work, right? Traditionally, pretty much all our work are physical, right? And as in the advent of digital technology, more and more of our work are shifting to digital, right? More and more of our work are shifting to digital. But they don't all shift, all the digital work are not contiguously together, right? For example, like they more look like this, right? So this part where a salesperson have to, look at this CRM data and actually coordinate a meeting, right, and actually go there. This may actually just be a small part of the work that you have to do, right? So, you may have a QBR meeting there. You may have to do other things. There's lots of stuff that the salesperson have to do, right? So this may be only a small part of it, okay? So now, the physical work, they're the slowest one, right? Because we are the slow one, right? I mean, things that are shifted to digital, they can actually move a lot faster, right? And as we also learned that anything that's digital can eventually be automated as well through AI, right? AI is an automation of decision and action, right? So we can eventually automate this digital work, and they will become much, much faster than if we have to still actually do them, right? Even though they're digital work, right? If we are involved, right, then it's still slower than if we could just automate this entire process, right? Okay, so pretty much all the digital works can eventually be automated, right? And they can actually move much, much faster, all right? Now, basically, the slowest part of our work remains is the physical work, right? So what can we do? What can you as a business do? What can you do? Well, there's two things you could do, right? One is that you could actually shift more your work to digital, right? So that involves what we call digital transformation, right? What's another thing that you can do? Another thing that you could do is that you can actually directly automate your physical work, right? How do you do that, right? I could use IoT and sensors, right, to sense the environment and the world, right? And we can actually use robotics and autonomous AI to help us automate some of this physical work, right? So this is actually here today, right? And this is actually on UC Berkeley campus where I graduated from, right? This little robot here is a delivery bot. It's a Kiwi delivery bot. It actually goes roam around the campus delivering food, documents, everything, right? This is actually happening, right, today. Now, the Kiwi bot is very cute. Actually, if you actually walk in front of it, you could, when you want to take a photo of it, you actually stop and smiles at you, right? So it's actually a very, very harmless robot. But this may be the robot today. In the future, the robot may be like this, okay? So that's pretty scary, right? So how can we prevent a doomsday by Terminator? How do we prevent that? How do we prevent that? Okay, think about this for a while, okay? Now, AI and IoT are actually in its infancy today, right? We are actually, like barely scratching the surface of AI and IoT today, right? But this infant, just like a human child, it will grow, right? And it will learn, right? And learning for these AI and robots is constant, right? They learn everything, right? Learning is complete. They learn everything that you have access to data for, right? It doesn't learn just what you want it to learn, right? And the learning is actually very, very fast. And the thing is that they actually never forget, right? So over time, eventually, they will actually be smarter and better than everything that we do. Now that's pretty scary, right? Is that scary? That is scary, right? But let me ask you guys, are you afraid of your children? Our children are basically like this, right? So why aren't we afraid of our own children? Because we teach them, right? But think about these robots and AI, right? They learn from data. Who generates those data? Who do you think generates those data for them to learn? They learn from us. They learn from every decision and action that we take, right? Because those decision and action generates data that they learn from, right? So really, to ensure that AI don't kill us, right, and robots don't kill us, the best way is that we need to learn how not to kill each other, right? We need to learn how to not kill each other. We need to learn to be better humans. We need to learn to be more compassionate, more environmental, more empathy, right? Have more kindness, exhibit more kindness to each other, right? That's actually the best way to ensure our own survival, okay? Because AI is going to learn everything, right? If we exhibit these behavior, AI will learn to exhibit more behavior like human, and they'll be more kind to us when we need them to be one day, right? Okay? So now you may think that this is impossible, right? In this competitive world today, where we have to struggle to survive, right? How can we be kind and be compassionate to each other? It's very, very difficult, right? Now it is hard, but we should not use today's standard to make judgment about a world that's far away in the future that we are not familiar with, right? Because today that may seem impossible, right? Because we have to work, we have to survive. But in the future, we may not need to work. We may only work. I'm not saying that we don't have to work, right? We nobody work, right? I'm saying that in the future, we may not have to work to survive, right? We may actually only work on things that we're passionate about, only do work that we love to do, right? Because AI could actually automate a lot of those work that we don't want to do already, right? All right? So it is foreseeable, right? And moreover, there are some Nordic countries actually experimenting with universal basic income. They are giving basic income to people, right? So people don't have to work to survive, right? In that world, maybe it's possible that we can actually learn to be kind and be more compassionate to each other, okay? So in the 20th century, the most terrifying technology is a nuclear weapon, right? We learn to live with that today, right? Nuclear power exists, right? We learn to leverage its power in generating energy for us, right? And we learn how to control the damage that it can make. So that's in the last 100 years. In the next 100 years, the 21st century, right? The most terrifying technology may be AI and robotics, right? And I'm sure that we as a human race will learn to cope with that and live with that in coexistence as well. So maybe with the help of AI, we can actually be better humans. And I still have faith in humanity. So thank you for your time.